Good morning, everyone. My name is Reto Meier. I'm a developer advocate here at Google. Now, technically, I'm a DA on the Google Cloud DevRel team. So if any of you bump into my boss or, really anyone from the Google Cloud team, and they ask how the presentation went, if you could tell them that I presented how to build a cloud backend for your mobile app, that would really help me out. Now, what I am presenting is hopefully what everyone is here to see, is Android Protips, a fresh look at expert advice for advanced Android developers. As the title suggests, this will be a very technical talk. There will be a lot of code. If you're not comfortable with code, or if you came to hopefully see the Grateful Dead, you are in the wrong place. You're also about 20 years late. Now, just to get a feel to make sure we do have the right people in the audience, how many of you are developing for Android right now? Not now, but like at home and at work. OK, most of you, not everyone. That's cool. Like there's some Android curious folks here, some deadheads in the wrong place and time. I think there's some folks up on the bank just working on their tan, and that's cool too. Everyone's welcome. Thank you for coming. Now, this is actually a pretty special year for Android. This marks the 10-year anniversary of Android development, which is super exciting. Obviously, not everyone's been developing on Android for quite that long. How many of you have been developing for more than 2 years? Yeah? Wow, most 5 years? A few hands down. What about 10 years? Do we have any 10-year veterans? A few. Nice. Congratulations. Yeah, a round of applause for the 10 years. I too have that honor, that privilege of having been developing for Android for 10 years. I even brought receipts. This is my very first question on Stack Overflow. It's asking about the Maps API for the 0.9 beta SDK, which those handful of 10-year veterans will hopefully remember, maybe hopefully not remember. This is not my first Google I/O. This is not my first Pro Tip session. So I'm curious, and this will be the last question I ask for a little while at least. How many of you have been to a previous I/O and seen one of my previous Pro Tip sessions? That's a decent handful. All right, and you still came to this. All right, that's reassuring. So thank you for that. I actually spent a fair bit of time over the last couple of months looking back over these sessions. And at first, it was because I wanted to gain some inspiration. Like, what are the cool things we used to talk about? Gain some of the excitement from the early days of Android. But I quickly realized that not everything that I had said in those early days has held up all that well. So as a result, what I'm actually going to be presenting this year is looking at all of the things that we've said in previous years and giving it a bit of an update. So the real title slide for today's session is actually Android Pro Tips Fixed. Sorry. So the goal here is to provide you with all the tips and tricks and best practices and good advice that's going to help us develop great apps for the next decade of Android development. And in order to do that effectively, I want you to take the same journey as me. So we're going to start by going back in time. We're going to go back through previous Google I/Os, previous Pro Tips sessions, all the way back to the very, very beginning. OK, we may have gone too far back. This is me in kindergarten, happy child. I don't know what a fragment is, and I've never heard of a content provider. That will change. Also, side note, I didn't know I was presenting in the amphitheater and that there would be a 400-foot screen. If I had known that, I may have included fewer pictures of myself. Take note if you're ever in this situation. Clearly, we're too far back, so let's just bump it a few years forward. I think I can do that with one of these buttons. Let's have a look. Yes. Yeah, this is more like it. Don't I look young? This is 2008, and I remember this because this is actually the cover photo for my first Android book. And we took this photo just after I'd gotten the first round of editor notes back from the first draft. And the next day, Android released the 1.0 SDK. And up until then, I'd been writing based on the 0.9 beta. And I knew it was coming. The clue is in the name. But I figured, how much is going to change, right? 1.0 from 0.9, 0.8 to 0.9 was pretty minor. So it should just be a couple of little things. Turns out a lot can change. Like, really a lot. I'd actually written an entire chapter on the gtalk data API, which was pretty cool, but it did not exist in the 1.0 SDK. It was 30 pages of hard work. I didn't remove it. I ended up leaving it in the book because by the time it came out, who knows, right? Android moves quickly. Well, it's been 10 years. It never got put back in, and eventually I removed it from future revisions of the book. Anyway, the reason I mention this is because I've spent most of the past 10 years going around talking about Android, giving advice on the best way of doing things, the latest and greatest APIs that you can take advantage of to build great apps. And I do this with the knowledge that sometimes within months, even weeks, and these things are going to change. They're going to be replaced with something more efficient, more comprehensive. And in fact, weeks and months is a best case scenario. I remember one particular incident. I had just finished a keynote, very exciting, Google Developer Day in Prague, I think it was. What's new in Cupcake? I've been doing this for a while. And I stepped off stage, and just as my foot hit the ground, we released Donut. So in that instance, I had about 3 nanoseconds of being current before everything I said was effectively outdated. Now, despite how all of that may sound, this is actually really a good thing. Well, for you, not so much for me, but for you it's a good thing. It demonstrates how quickly Android is evolving to take advantage of or to give users and developers the things that they need to be able to be successful. There's always been a trade-off, and I know you all have felt this pain, where a new platform comes out, awesome new APIs, great new functionality to take advantage of, but you know it's going to take a while before lots of users are on that platform. And at the same time, you know some of the older platforms are going to take a few years before they go away. So you have to do this trade-off. Is it worth putting in the time and effort to take advantage of the new APIs, the new functionality, knowing that it's going to have to be backwards compatible and you're going to have to maintain that code potentially for years? So when do you do that? Well, the thing is, what makes us really excited is that now we have Jetpack, right, which incorporates all of the Android support library, Android architecture components. And if you take Jetpack and combine it with Google Play services, we end up with an increasing surface area of APIs which don't rely on having the latest platform version. So you can take advantage of the new functionality that's available, and we'll take care of writing all of the boilerplate code to make it backwards compatible for you. Right, so this is a nice advantage, right? Suddenly that trade-off isn't quite as expensive. Now it's still, one of the big pluses of this as well is that we're no longer tied to the framework, right? So we can continue to launch new features, fix bugs, encapsulate more best practices, take care of more edge cases. We can do all of this in between platform releases, which is great for developers, not so awesome for those of us trying to talk about it. Things change more rapidly. But there's a price, right? If you want to take advantage of this cool new stuff, you'd have to reconsider some of the fundamental architectural choices in how we build our apps. And so I'm going to talk today a little bit about why I think now is the right time to do that. But if we bring it down to its real fundamentals, what we're trying to do is keep our app looking fresh, lightweight, full of potential. If not, we quickly risk becoming visibly older, outdated, a little bloated maybe, harder to maintain, harder to manage. And I don't know, there's an analogy for high cholesterol, but I couldn't figure it out. You get the idea, right? So before we sort of dive into some of the tips which we do need to update, I did want to spend just a little bit of time highlighting a handful of pro tips which have stood the test of time that, like a fine wine or a sharp cheddar, actually age pretty well. There's probably more than just the ones on this list, but this is the highlights. And what you'll notice about these particular pro tips is that they're not really specific to Android. They're not even really specific to mobile development. This is just good best practice that you should always be keeping in mind when building any engineering app. So let's not dwell too much on the things that we know are still good ideas. Let's take a look at some of the things which have changed, which have perhaps not aged quite as well. Now, everything on this list you can pretty much still do, but it's all been replaced with newer APIs that are more efficient, that encapsulate a bigger amount of functionality. Sometimes the underlying hardware's changed or the UI paradigm has changed, but a lot of it you can still do. And that's actually kind of a theme for a lot of the things that we're going to be looking at. There has always been ways of achieving certain things, but there's now significantly better ways. Simpler ways which involve less code, less hacky workarounds, making it more predictable and easier for you to maintain and manage your code bases going forward. So we know things have changed. I've said that a few times, but there's certain things we've always been able to rely on, right? You write your Android code in Java language syntax, and all of the application components are basically the same. You know, we use these same core components, they interact the same way, they achieve the same end results. And that's something we've been able to rely on basically until now. The last year or so, things have fundamentally changed. Android Studio 3 introduced Kotlin as a first-class language for Android development, and that's actually what we're encouraging people to use as their primary development language for Android. We saw the introduction of Android architecture components, which introduced view models, live data, and the room database to significantly simplify the way that we manage data and have it interact properly with the activity lifecycle. We also have the job scheduler, which almost entirely eliminates the need to create your own custom background services, and the intent receivers that we sometimes set up to monitor device state to control when our services are run, which is a good thing. Because in Android O, we actually deprecated the ability to have long-running background services when your app is in the background as well. And at the same time, most of the intent receivers that you may have used to monitor device state have also largely been deprecated. Another good thing, of course, things move quickly. Job scheduler already deprecated as of yesterday morning. So now we have work manager, which is nice because it does the same stuff as Job Scheduler, but it's backwards compatible, right? So you're starting to see some of the trends of what we're trying to achieve here. So we should dig into some of this stuff in a little bit more detail. It's something which I've talked about at most of these Pro Tips sessions. It was the first thing I talked about and comes up every year. I like to focus on what's happening in the background. Sometimes it's easy to miss until you really focus on it. So the first pro tip I gave back in 2010, first Android session, first real session on a big stage, was very exciting. And this is the first pro tip. So I thought, let's have a look at what I said and see how well it holds up. So this is the first thing I ever advised.
So it's important that you move anything which can in any way take longer than just a fraction of a second and interrupt the UI flow, that you move it into a background thread. So there's a number of ways you can do that. The most simple and straightforward is, of course, just to use Java threading. What we've created in Android is a class called async task.
Yeah, you know what they say, the giant screen actually removes 20 pounds. So it's kind of true, right? Like we don't want to block the UI thread. The context around what I was talking about was trying to eliminate these application not responding dialogues, which have evolved over the years. They look a little bit different now. They used to be very common because it was easy to block the foreground thread, right? If you tried to do a data transfer, for example, it would block and that would be a bad experience. And so for Android 3.0, we introduced a runtime exception. So if you tried to access the internet through a runtime exception, the app would crash. Strong encouragement for developers to not do that. More recently, we've done similar things with file system access, with database access as well. Now in Android P, this is no longer a problem because we don't show in and out dialogues. We just crash the app. So that's not a better outcome for your users, but it's a much stronger signal to us as developers that we need to make sure that we're taking care of this particular problem. Now I did mention one solution, and it got some love, the old async task. It's a reasonable solution to the stated problem. We need to move everything off the foreground onto a background thread, and that's what async task does. It creates a background thread, and then it has these two handlers which are called, marshal back to the UI thread so you can update the UI when you've got progress or a final result to display. I would like to tell you that the only thing missing from that is that now you have to write it in Kotlin. It's better. Kotlin looks nicer. It's certainly more concise. But you still have the same fundamental problems, where if you're doing this stuff within an activity, if the user rotates the phone, it's all going to go wrong, right? Your thread's going to get killed, your async task, and that's kind of your best case scenario. You may leak context. You may try and update a UI element that just doesn't exist, or is in the process of getting killed and recreated. It's problematic. Now, back in that first I/O session, I had a solution for this. It was a great solution. The advice was, you should move it to a service, which it's fair to say this advice has not aged spectacularly well. Now, the general principle is still pretty reasonable, right? It's like you have something long running. So you're in your activity, you use an intent to start a service, probably an intent service, and that goes and does the time-consuming work. Maybe it's pulling something down from a server or interacting with a database or performing some complex calculation. And when it's finished, it sends an intent back to the activity, and it then updates the UI accordingly. It's basic stuff, and it's a reasonable approach, but it does introduce some new challenges. Services are heavyweight components, right? We don't really want to create them. We want to kill them as quickly as possible to gain back some of those system resources. And they keep running, even when your activity isn't, which is kind of the point, but now you have to keep in mind your activity lifecycle. What's it doing? Have you actually exited the app? Have you transitioned to a new activity? Should the service keep running? Should it be canceled? All of this stuff you need to keep in mind, and it's doable. It's just a lot of work to get right. And of course, because services run at a high priority, it actually prevents the system from killing your app to gain resources if it needs to. And there's no guarantee that your service will actually keep running if your app is forced quit. So there's another problem, which is in Android O, you can't guarantee that your background services will be running when you want them to. You can't start a background service when your app is in the background from a broadcast receiver, and they will be killed after a few minutes, even if they were initiated while your activity was in the foreground. Now, for really time-consuming things, which you need to have run, this is still a reasonable approach. You have an activity, uses a service to then download data from a server, say. It's a nice time-consuming operation. And then that saves it to a database. And then your activity just monitors the database. So it's kind of a one-way flow, which is nice. But there is a catch. There's always a catch. And the catch is that this is not an efficient way to use the cell radio. And back in 2012, I'm not going to go into too much detail, but I had this whole spiel about how the cell radio works. And every time you do a transfer, it turns on the radio. It stays in a standby state, which draws more power. And the goal is that it reduces latency for future transfers. That's all great. And the reason it's important for us to know is that if you're doing lots of transfers, you can keep the radio turned on. It's going to draw power more quickly. And so we had some specific advice for this, which was, you should deal with that. You know how it works now. Efficiency is important, so fix it. I had this whole metaphor to help. It was about cookies. I have a friend who's an artist, and this is an excuse to get him to draw things. And the idea here was to use the big cookie model, where you're minimizing the total number of transfers that you're using across the app lifecycle. So if you have something that's not time sensitive, like analytics, you queue that up and wait. Next time there's a user-initiated refresh, you send all of the queued data. You also look into the future to see, is there anything which is going to be scheduled to happen in a few minutes, and let's just do that first. So it was a way to manually batch and bundle all of your transfers so that they happen at the same time, and you get some increased efficiency. Now, as I'm sure you can believe, doing all of this and understanding how to do it right was complicated enough that a room full of engineers, much like yourselves back at Moscone, believed that this was a legitimate equation you needed to solve in order to figure out how to do this right. It's not. This is just made up. By 2012, we had a solution, which was the sync adapter. And the sync adapter, we claimed, was pretty straightforward, which is fair to say was a lie. Now, it's still better than doing it all yourself. Once you set it up, it's not that complicated, right? You're able to trigger a one-off or a periodic transfer, and the sync adapter will handle all of the background work, doing the batching and time shifting for multiple of your requests that happen within a sort of time window. So you don't have to think about when you trigger it, you just do and trust the sync adapter to handle the timing for you. Unfortunately, to make this all work, you needed to have a sync adapter, fair enough. Sync adapter runs within its own service. Of course, you also need to have an account manager, which isn't used, but it's part of the API, and the account authenticator also needs its own service to run in. Okay, I'm seeing a trend. You also need to have a content provider. Again, doesn't need to be used, but needs to exist. You do all of this, write it all in Java, and then there's maybe a dozen XML files you need to write as well, plus some manifest changes, and then you're good to go. Your sync adapter works. It's fair to say that a lot of people trying to make this work found it to be kind of frustrating. And of course, it only batched and bundled your app, your transfers within your own app, which is why 2013, great year, Android 5, we introduced the Job Scheduler API, which has now been replaced. Job Scheduler works at the platform level, so it does the batching and bundling for all of the apps at the same time to be able to take advantage not just of cell radio battery improvements, but all of the resource improvements that we're trying to do, things like standby, doze mode, all of this. So within your app, you create a new job service that does the asynchronous background updates. In this case, we're using the async task, which we can use now because we don't have the same memory leak problems. And then within your specific activity, you just define the criteria that you need in order for that job to be successfully executed. If it needs to be on the internet, it needs to be charging, etc. How urgent is it? What is your preferred timing? Is it periodic? All of that sort of stuff. And the job scheduler will then handle all of the background work for you in the most efficient way possible. The only thing which would be better than the job scheduler is if it worked in a backwards compatible way, which is why we launched Work Manager, which is part of Jetpack. Now, to use Work Manager, it works basically the same way. You create a new worker, and that is where you're defining the background work that needs to be done. And then within your activity, you do the same thing. You specify the constraints that need to be met before this work can be accomplished. And then Work Manager will handle all of this for you in the background, same as Job Scheduler, but it now also encapsulates the best practice solution for earlier platform releases. I think it goes back to 4.4. So it'll use the latest and greatest job scheduler if you're running on the latest platform, all the way back to probably Alarm Manager for some of the earlier platform releases. And again, you don't need to write any of that boilerplate code for backwards compatibility. We do all of that for you. So you don't have to maintain it, find the bugs, find the edge cases. You can rely on Work Manager to take care of that. And of course, this is going to continue to improve in future releases. So as Job Scheduler continues to improve on the platform, Work Manager is going to be able to evolve to take advantage of some of those changes. You can learn all about Work Manager and Stage 2 today at 5:30. I recommend going along. It's a really cool new API. So Work Manager, it's great if it's something which is genuinely time-consuming and it needs to be initiated on the client side. Now, one of the things which we've always said and which really hasn't changed is that wherever possible, you should eliminate periodic refreshes, and any updates that need to happen based on changes on the server side should be initiated by the server, preferably using Google Cloud Messaging, by which, of course, I mean Firebase Cloud Messaging, because GCM was deprecated in April. Things move quickly. Now, Firebase Cloud Messaging takes advantage of the same scalable, reliable GCM infrastructure that we've been using in the past, but also improves delivery reporting and reliability. It also adds a web console so you can send notifications to your apps without having to have your own server instance. Now, for transfers, this gives us a pretty good solution, but there's really no way that this is a viable solution for being able to maintain a small amount of data whenever the phone rotates. And for that matter, using singletons or overriding the application class, which I may or may not have said in previous years, is similarly considered somewhat distasteful. So, which is why in Android 3.0, we introduced headless fragments and loaders. I assume everyone's familiar with both of these. Fragments were designed to break your UI up into chunks that were independent, reusable, and interchangeable. And the key here was they were also aware of the parent activity lifecycle. Now, the trick with headless fragments was that they didn't have a UI. So you could configure them to be retained across an activity restart based on a configuration change. And this is really nice because it meant now we have somewhere to store our data model that's independent of the activity being recreated every time the configuration changes. But managing fragments was tricky. And if you attended the first Android session this morning here, you see just how tricky it was. You can add and remove fragments from any activity. You can have multiple instances of the same fragment within the same activity. The fragment transactions are all done asynchronously, so you can't guarantee when something is there. And it's got its own life cycle to manage. Now, none of this was great. Right? You were able to achieve what you wanted, but it was complicated to make this all work. Now, loading was better. Loaders made it easier to asynchronously load data within your fragments and activities. And then you could observe and react to changes in the loader within the activity based on whenever the underlying data changed. And in most cases, you had to handle all of that plumbing yourself, which meant you needed to load the data from wherever it was stored. You needed to then observe changes within that underlying data and bubble it back up through the loader so that you could have the simple code in your activity, which was unless you used Cursor Loader. Now, Cursor Loader was great because it did most of the work for you. You initialized the loader within the activity or fragment at creation time, and then you just filled in a number of callbacks to create a new cursor and then to receive the results so that you can update the UI accordingly. Now, initializing a cursor loader was pretty straightforward. You pass in the authority of the content provider that you want to query and the SQL statement that you want to use to get back your results. All of that gets passed into a content resolver, goes to your content provider, and gets you back a cursor, which you can then use to update your UI. But by definition, that meant that you needed to make your data available via a content provider. And content providers are, actually, you know what, I'm going to come back to content providers. I'm just going to leave them there for a moment. So, okay, so take a step back. We've got headless fragments and loaders, and technically that enables us to do everything that we need to do. There's a problem, though. It's really hard to get them to work together, understand how to make them work across multiple activities and fragments and the various different implementations of both. In fact, getting it all to work reliably and well was, again, it was frustrating, which is why we're also excited to see Android architecture components. Android architecture components introduce view models, live data, and the room database. And this all effectively replaces fragments and loaders as a simple way to separate your UI and your UI data. The view model itself is actually really simple to create. You start with a property that stores the data that you want to expose. In this case, we're using a mutable live data, because live data is cool. And then you expose a method which is going to return that property. And so the first time it's going to populate that property, and then from then on it will return that cached version. Then you have a method which does that population, and again, this is done asynchronously. In this case, again, we're using our old friend, the asynchronous task. Then whenever the value of your mutable live data changes, that is going to trigger any observers that you have attached to it. So back in your activity, all you need to do is request the view models, ask for the specific view model class that you've just created, and then call that view model's data access method, which will either then populate the data and return it. Either way, you'd add an observer to that, and then your observe trigger is going to get called both the first time you attach the observer and then any time the underlying live data changes. Now, the beauty of view models is that they survive activity restart, so we don't have to deal with that particular scenario. And the beauty of live data is that it understands the activity lifecycle. So the first time the app is run, your view model gets created, populates the live data from the underlying data source, sends the results back via the observe handler within your activity, and then, if someone rotates their phone, the activity gets destroyed, gets recreated, but the existing view model is returned. The existing live data is returned via the observe handler, and it's triggered with the latest version of the data, whether it's been updated or not in the interim. In fact, live data is really smart because it only sends updates via the observe handler when the activity is active, because you don't need to update the activity if the UI isn't actually visible. And if there is new data, it will wait and then transfer it once the activity becomes active. So as a total result, what we do is we feel less like this and much more like this, which is always our goal. Content providers. I promised I'd come back to content providers, and just as some context, this is what happens. This is the number of students enrolled in each of the lessons of our Android Udacity class. And as you can see, the highlighted columns are when we get to content providers and loaders. So you get the impression this is something that people find a little frustrating. We've improved it since then. It's not quite so grim now. And some of what we're going to talk about now actually explains some of those improvements. Why is it so frustrating? Well, this is the boilerplate code for creating a simple content provider. I'm sure many of you have built something like this. In truth, it's really just the first couple of methods. It goes on for a little while. And now, keep in mind, this isn't doing anything particularly special. It's just passing content resolve requests straight through to a SQLite database. Now, obviously, that's just the content provider. Then you need to create a contract that defines the column names that you want to use to be able to interact with it. Then, of course, you need to create your own SQLite open helper, which is how you create, update, and access the underlying database. Now, all of this operates on cursors, which is probably not what you're using in your UI. So you'll need to create a class to represent the records in the database, which is nice. It's actually quite simple in Kotlin. But you'll also need code to convert between those class objects and content values to add rows to your tables. And you'll need to be able to convert between cursors and lists of your class objects. Somewhere along the line, you need to set up a bunch of observers so that if the database changes, your list of objects also gets updated. It's a lot of code for something which should be relatively straightforward. Quick one, is there anyone here who gets paid per line of code? No. OK. So if there is, and you were just too shy, that old method actually works really well. Stick with that. For the rest of us, this is where the room database really comes into its own. So it's part of Android architecture components, now part of Jetpack. And all you need to do is you start with the class definition, right? Defines the columns that you want within your class. And you just add an annotation to say, this is an entity that I want to use in a database. And this is the primary key for this table. Then you create a new room database, which includes each of the tables that you want to have within that database. And you return an instance of the data access object. And that is the class where you specify all of your database interactions, your inserts, deletes, updates, and your queries. As many of them as you want in as many different styles as you want. Now, you'll notice that the queries here return live data. And that's really cool, because if you're storing your UI data in your view model, which obviously you are, because that's the right way to do things now, it actually simplifies that view model significantly. You just request access to the room database's access object, execute the query, which returns live data itself. Then you just pass that live data right back through to any activity or fragment which requests it. Back in the activity, it works the same way. You've got the same observe handler, you're getting the same live data representing a collection of objects, and you can use that to update the UI whenever the underlying database changes. So you've got the same outcome that you did before, but 10 times less boilerplate code. 10 times less code that you have to maintain and alter. If you change a column name beforehand, it was a lot of places that could go wrong. Now you just modify the class. Now, if you combine that with the work manager, you actually get a really clean solution to this whole process, right? The work manager downloads data from a server. It updates the room database accordingly, which then sends the live data to the view model within the activity and fragment or fragment that you want to use, which then, via the observe handler, updates the UI. Right? So if you're not one of the lucky folks who are still getting paid by line of code, this is probably a better solution. Right? So speaking of better solutions, what else have we got? I wanted to talk a little bit about Android location services, because this is, again, a topic that I spent a lot of time talking about. Being able to find the current position and put it on a map somewhere is something that's been part of Android since the very first beta SDK. And so by 2011, I'd actually managed to amass quite a collection of pro tips for how to take advantage of the location manager in the most efficient and effective way possible. It was a big topic in a couple of my Android Pro Tips talks. So I went to the location team and said, I've built a project which encapsulates all of our best practices, all of the things which we tell people to do. And it's fair to say that they were impressed, by which I mean it really left an impression. They then went away and did what they do, which is fixed everything. And so where beforehand I had all of these classes and interfaces, they went away and gave me an API as part of the Fuse location provider, which does all the magic for you. It encapsulated all of those best practices within a small number of simple APIs. All you need to do here is tell it what's more important, battery life or accuracy. How often do you want to get results? And the Fuse location provider goes and does all of the hard work for you. Now that said, things have changed a little bit. In Oreo, we made some changes, some new restrictions about how you can receive location updates while your app is in the background in order to save battery life. And specifically, that means that if you are in the background, you only received updates from Location Manager or the FLP a few times an hour. There's a few ways that you can deal with this, right? You can make a foreground service, which is what we do with navigation. Another approach is to use geofences. So for those of you who remember the very first version of geofencing on Android were proximity alerts. Proximity alerts were bad. Easy enough to set up, specify a lat long, a radius around a point, and they would fairly reliably trigger if you went across that boundary. Now, the challenge was the way that it achieved that was by turning on and leaving on your GPS. So as long as you had a proximity alarm set, it would keep the GPS running permanently, which is not what the documentation said, but it is what happened. Now, luckily, the same Google Play services launch, which gave us the Fuse location provider, also gave us a real geofencing API, which had all the functionality that was claimed to be done with proximity alerts, but also gave you a few additional improvements. Most important of which was that it didn't keep the GPS locked permanently on. We can take our geofences to the next level with the Awareness API, which adds additional context signals which allow us to make more complicated fences. Specifically, we can add date and time, proximity to beacons, user activity if they're walking, cycling, driving, and device state. And you can combine all of those conditions together, such as in this example, where we have one fence which is triggered if you drive within 1,000 meters of a given location between 10 and 6. We have a little bit of time left. One thing I learned in 2018 is that there's a new way to, there's a new way to control media. Right. Now, back in the day, controlling media playback was done with the media player. I'm going to buzz through this pretty quickly. Mainly, it meant that you had to listen to media buttons getting clicked. Now, of course, you can control media a bunch of different ways. So we've got a better solution, which is ExoPlayer, which effectively replaces the framework media player. It's easy to customize and extend. Again, I'm not going to go through the full details here. I had a couple of slides, but I have been speaking too slowly, so I recommend that you go to Mark and Andrew's talk tomorrow morning at 10:30 to get all of the details. Now, not all of the changes in Android have been in code. Some of the biggest changes are actually in the availability of Android expertise. Back when we started, we didn't have Slack and Google Developer Experts. We didn't even have Stack Overflow. What we did have was IRC, we had Google Developer Groups, we had some DevRel people which spoke at conferences, and that still kind of happens. But the big change now is that we're just voices within a much larger developer ecosystem. There are now lots and lots of people around the world who help each other. This is just a small selection of the 90 Google Developer Experts specializing in Android and Kotlin all around the world. So there's just a small amount of the extended engineering team that we have helping the community. Similarly, we've got Android conferences all around the world. This is a small selection of some of the Android events that people pointed out to me on Twitter a couple of weeks ago when I asked what the best conferences to go to were. Because really, the biggest tip that I can give you is that much more than changes in the tooling or the frameworks or the APIs or Jetpack or anything else, much more than that, the biggest thing driving Android development forward is the community. It's the people around you, the people online, who are all helping each other with Android. And it's important because we know that the one thing that doesn't change is that things are going to change. So take advantage of things like Jetpack to make things simpler, work with the people around you, and hopefully your apps will survive much longer than my pro tips. Thank you.